Welcome. Today we are going to solve 3 problems under the topic root locus. So coming to the 37th problem, the open loop transfer function of a unity feedback control system is g of s equal to k by s square plus 5s plus 5. The value of k at the breakaway point of the feedback control system's root locus plot is. So they have asked to find the value of k at the breakaway point. So to find the breakaway point, the procedure is just write the characteristic equation. So they have given the open loop transfer function and it is said that it is a unity feedback system. So the characteristic equation is 1 plus g of s h of s. Just substitute and get the equation, that is characteristic equation. And from that characteristic equation, just bring all the s terms on one side and k. Write the equation in the form of k equal to minus s square minus 5s minus 5. So if you differentiate this equation, you will get minus 2s minus 5 and then equate to 0 to get the value for s. So this is the point at which the break point occurs. So this substituting s equal to minus 2.5 in the equation. In which equation? In this equation, k is equal to minus s square minus 5s minus 5. So you have to substitute s equal to minus 2.5 in this equation so that you will get k is equal to 1.25. So the answer is k is equal to 1.25. So coming to the 39th question, a unity negative feedback system has the open loop transfer function g of s equal to k by s into s plus 1 into s plus 3. So the value of the gain k at which the root locus crosses the imaginary axis is. So they have asked to find the value of k where the root locus meets the imaginary axis or it intersects the imaginary axis. So whenever the root locus meets the imaginary axis, you can substitute s equal to j omega because the real part will be 0. So coming to the first step, just derive the characteristic equation. The h of s is given as 1 because of unity feedback and g of s is k by s into s plus 1 into s plus 3. Just substitute in the characteristic equation, you will get the equation s cube plus 4s square plus 3s plus k equal to 0. So now the root locus meets the imaginary axis. So the s, just substitute the value for s j omega in this equation. In which equation? In this equation. Okay, and just by simplifying this and just equate to the real and imaginary parts separately. So just separate the real part and imaginary parts and just equate to 0 because the real part is also 0 plus j 0, imaginary part is 0. By equating the imaginary part to 0, you will get omega is equal to plus or minus root 3 radian per second. By substituting omega in this real part, you will get the value of k is 12. So hence the solved. So coming back to the question number 42. So the root locus plot for a system is given below. They have given the root locus plot here. The open loop transfer function corresponding to this plot is given by. So you have to find the open loop transfer function from this root locus plot. So we'll just see how many number of poles are there. So here and a pole is there in the origin and in at s equal to minus 2 and s equal to minus 3. So on seeing the root locus, you can find there are 3 poles, but actually if you see this pole, the root locus starts from this pole and ends at the finite 0 because there is only 1 0 here, and remaining 2 poles starts from their respective place and goes to the infinite zeros. So this one goes like this and this one goes like this. So they meet at infinite zeros. And coming back here, see there is another root locus branch starting from minus 3. So it implies that there is another pole, that is you should have if there is a branch here, then there should be odd number of poles to the right of this branch. So when you consider right of this branch, okay, there should be odd number of poles, right? 1, 2, 3, 4. But here only 4 number of roots are there. So, but it is given that there is a root locus in this part. So it implies that this pole, there should be 2 poles in at this point, that is s equal to minus 3. So there exists a root locus from minus 3 pole to minus infinity. So there must be an odd number of poles and zeros on the right. So therefore there must be a double poles or repeated poles at s equal to minus 3, which implies that the poles are 0, minus 2, minus 3 and again minus 3, and zeros is minus 1. So from this, just substitute in the characteristic or open loop transfer function, you will get this equation. Hence solved. Thank you.